Welcome to my coding channel, Coding Learning. So today we implement a quick sort in C++. So I created a swap function which swap the values, and there is a partition function. I discuss it about later. The first discussion is about the quick sort. It is the similar to the merge sort. First we are place the array as an argument, and then the starting index and the last index, which is denoted by r. And it first check if our L is smaller than r, then we come in this part and we find the pivot element index. So thus we are calling the partition function, where we pass the array, the starting index of an array and the end index of an array. So first we suppose that our pivot element is are the last element of the array. So this is how I assign the pivot element by 35. So this is the input array 23, 56, 11, 22, 33, 44, 35. So then we initialize our variable I with L minus 1. Here the L is 0. It means that I will be denoted to the somewhere here, and we are call the loop is started from j is equals to L to j is smaller than equals to r minus 1. So it iterates till here. So if our array j element is smaller than the pivot, then we incremented the I index and we just swap it out. We swap the ith array element and the arrayth j element. So initially I will be here and our j will be here. We find that our 23 is smaller than the pivot element. Thus, the I will be incremented and there is only the j will be at the 0th index as well. So it doesn't require any swapping. It's just incremented I by 1, and now the I and j will be at the same position. And after the one iteration, we incremented our j. So here our j will be at this place and I will be at the previous index. So again we check if our array j element is smaller than our pivot. It is not right now. We just move forward, and now j will be incremented by 1 again. And here the j will be placed at here, and we find that our pivot element is greater than our jth element. So we need to swap the element. I incremented the I, so in the previously the I will be here, and now by the incremented the index of I we are at here. We swap the value of ith index and j. So we are calling these function, the swap function. I takes the argument as a pointer so that we easily swap the values. If you are not familiar with the pointer concept, please check my previous video which is based on the pointers. So let's move. So here we swap the values, and now our arrays look like that. Now, so now our j is at here and our I will be here. We find that the jth index element is smaller than our pivot. Then we swap the values, and now the after the swapping the 22 will be here and 56 is here. Then we incremented the j by 1, and now our j will be at here the 33, and we find that our jth element is smaller than our pivot. So we simply increment our I, and then we swap the ith value with the j. Let's move. So again we need to swap the values, and we find that our 33 is at here, and then the j will be incremented by 1, and now our j will be at here. We comparing the both element, we find that the 44 is greater than 35. Then we just stop, and then we swap the ith array I plus 1 element with the r or our pivot element. So simply we swap these values. This we incremented our I plus 1, and we just simply swap the values, and we find that the pivot element is placed at the correct position because all the elements before the 35 are smaller than the 35, and after the 35 all the elements are greater than the 35. So we simply divide the array And then we call the quick sort again for the starting position to the pivot -1 position for the further partition of an array. And then we call the quick sort for the right hand side, which starts from pivot +1 to the last element of the array. So this is how the quick sort is work. Let's move forward for implementation. So now we are code for the quick sort. I create the swipe function first, which takes the pointer to pointer name as a and b, and we create the temporary variable which stores the a pointer, and our a pointer will be our b and our b will be our temp. So it's done about the swipe function. Let's call the quick sort. Return type will be void and takes the int type array as an argument, the starting index, the last index. First we check if our array is smaller than r, then we take a pivot element from the function partition, which takes the array, the starting index and the last index. And then we call the quick sort function again for the, we are putting here array, then the starting index and our pivot -1, which is the last index for our left hand side array. And then we call a quick sort function again for the right hand side, with where the starting index for this is pivot -1 and the and will be the r. So let's code for the partition. The return type of our partition is int, because we're returning the index of our pivot element. Takes the int array, the starting index and then last index. Now we create a int type pivot. Let's assume the last element of an array, and we create a variable I, which is l-1, and we create a for loop which started from j is equals to l and it scores to r-1, and each time the j will be incremented. We check if our array j element is smaller than our pivot. We just simply increment the ith index and then swap array I and array j. After the completion of the loop, we are simply doing swap function again for the and array minor array I+1 and array last element, and we just return I+1, which is the index of our pivot element. So let's save and run. I just So you can see that all the elements are arranged in the ascending order using a quick sort. So that's it about the quick sort. Let's move. For more videos, please like, share and subscribe.